kind of entitled this one The Hitchhiker's Guide to Machine Learning, mostly because I've been spending a lot of time doing machine learning and talking about statistics. I've actually been doing this long enough that I originally started talking about statistics, and now we're talking about AI. So my name's Randall. I don't do a lot of Twitter much anymore. I actually find if you really have a question for something, just send me an email. Like, I'm way more likely to get back to you over email than I am on Twitter these days for various reasons. Yeah. It's been a little abusive. I don't know if you guys have heard, right? But we started this company called Thunderbolt Labs. We've actually had a lot of great Rubyists that I've had the privilege of working for over the past several years. We ghostwrite software for people, so if you need some software written, come contact us. So the joke here is, unless you've been under a rock, you might have heard about AI. It's gonna get worse from here, people. It's not getting any better, all right? So how many people here have heard AI, ML? Actually, better yet, how many people have had like a salesperson run into their office and saying, what are we doing with AI? That's right. It's like, where's the ML? Where's the machine learning in our app? Right? So it's kind of a big deal these days. The problem is that we are in the middle of a gigantic hype cycle around things like machine learning, artificial intelligence, and all these words are being bandied about, and not necessarily in a good way, right? So here are the ground rules for this presentation. I'm about to tell you a way to get into machine learning, not the way, right? Because invariably somebody in here has a PhD in physics or econometrics, and they're gonna be like, but. That's because half the things I'm gonna tell you are gonna be wrong. Your job is to figure out which half, right? One of the things that you run into, especially when you look at machine learning and applied statistics, is that they're mostly written for other people who already have PhDs in applied statistics, right? So which means that in order for us to keep from going to dissertations that are mostly written in Greek, and for anybody here, trigger warning, math, like if you had that really bad final, you know, the one where you thought that you got a C and it turns out on the curve you got a D-ish, right? That's what we're trying to avoid in this talk, right? So I'm gonna have to lie to you and simplify, right? The other thing, we're gonna be talking about a lot of details, URLs, all this other stuff and resources. Don't worry about it. I'm actually gonna put together a list of these PDFs, like a list of these URLs in a PDF so you can just download them later. And I'll get ready to tweet it out over the Windy City Rails link. So you don't have to start like furiously copying anything, right? And the final thing is, come on, don't panic, right? There's no Vorgon construction fleet. We're not about to actually be liquidated that I know of. And if anybody actually has a Babelfish, let me know. So one of the first things that we actually need to talk about is the segmentation inside the machine learning environment. For a long time, machine learning was strictly the domain of people who were applied statisticians, econometricians, people who actually had PhDs and spent a lot of time doing math, right? We now put them at the top of this awful pyramid and we call them data scientists, right? These are the people who are essentially responsible for creating new types of machine learning and applied techniques, right? Beneath that, we've got ML engineers. That's kind of where I think most of the people in this room are going to come in. These are the people who are the applied practitioners of machine learning. They build the actual systems because, frankly, no offense to anybody in here who has a PhD, we've done a lot of work with pharma companies and we've seen some of the code that people who have spent 10 years getting a PhD have written in Visual Basic and Microsoft Excel. You do not want to do that. No offense to these guys, they are better at actually creating new methods of applying the stuff than they are at implementing it. Beneath that, we have data analysts. Data analysts, generally speaking, it's kind of an arbitrary distinction, but the distinction I make between them is that data analysts do not want to write code. If you want to write code, you are an engineer. I don't care. I don't care what your job title says. The second you start making commits, you are an engineer, so you have to follow the same rules. Analysts are not going to be writing code. And then the one at the bottom of this pyramid is the consumers. And this is a huge base because how many people here have like an Amazon Prime? Like, or an Amazon account, almost everybody, or how many people here watch Netflix, right? We are consumers of machine learning on a daily basis, whether you know it or not. If you bought a plane ticket to get here, you were consuming a machine learning algorithm that probably priced your ticket and screwed you over for a maximum amount of money, right? So these consumers are exactly what everybody's trying to get to. So one of the things that we've got to remember is that those consumers oftentimes do not even know that they are using a machine learning system. They do not know that they are using an AI system. So for the purpose of our talk, we can ignore them. Right? Data scientists. Trigger warning, this is the Greek that we're talking about. Bonus points to anybody who can actually recognize what that equation is. Well, clearly this is the ordinary least squares regressor function. Right? That's what makes data scientists data scientists. People with PhDs see that, and instead of twitching like the rest of us, they actually go, oh yeah, an ordinary least squares regression. Yeah, I knew that one. Right? Data scientists spend a lot of time manipulating symbolic math equations like this and optimizing things. Like, they are specifically tasked with creating, maintaining, and otherwise extending the domain of statistics and mathematics to make sure the techniques that we use in machine learning and AI are applicable. And if that sounds like an awful, horrible job, you do not want to become a data scientist. So there is one thing I wanted to talk about. I fucking hate the title data scientist, right? I actually wrote a rant about this because nothing that we're doing is science. It's not like we're doing like tested, tried, and tested like experiments and we're actually trying to advance things. Mostly they're trying to make sure that you pay exactly as much as you were going to for that thing on eBay, right? So sort of putting it into science, we're not there yet, right? It's the same way as like, I think one of the biggest disservices we ever did to software is calling it computer science. Anybody who's actually sit there and saw that presentation on React earlier, if that network of components looks like science to you, then God help us all, right? So it's really easy to become a data scientist. You go to college for 4 or 5 years, you get an undergraduate degree with a lot of math like engineering, you then go on and get a master's degree in some other really math-heavy subject, and you probably get a PhD in physics, econometrics, mathematics. So it's easy. Spend 10 years in school. Done, right? Analysts. We're not going to spend a lot of time talking about analysts because I'm going to assume, since you guys are all here, that you actually have an interest in the technology of writing code. Analysts, generally speaking, are using pre-built systems to try and otherwise engage and work with those systems, right? So, which brings us to this. This is what I assume you guys want to become, is some sort of machine learning engineer for a couple of purposes. Your boss told you you need it, you want to make more money, or you basically, people keep telling you about this stuff, and you're wondering if they're just all full of shit, right? So here's the succinct guide to getting into machine learning. You actually need to know some math. I know it's really popular these days to actually sit there and say, learn machine learning without math. That is bullshit. That's basically like sitting there saying, like, learn to ski without snow. What will happen is if you treat machine learning as a black box, you will never understand how it can break and when it's broken. And one of the craziest things about machine learning and applied statistics is that stuff that's broken looks exactly like stuff that is working, right? It's not even like red-green refactor. It's just, oh, it's 0.2. Right? Which leads us to the second thing. Once you get even a basic understanding of ML and the math underneath it, you can actually learn the basics of machine learning, AI, statistics, or whatever else we're going to brand it this week, right? And then you're going to have to learn a couple languages. How many people here actually write in more than just Ruby on a daily basis? Okay, put your hand down if it's JavaScript, right? Good, there's still some people here, right, that actually have more than one language. How many people here actually know more than one language and have actually learned another language beyond the one they need for work? This is all a good thing. The reason being is that if you're going to get into machine learning, you're going to have to learn multiple other languages, at a bare minimum Python. It's just the way it works. It's kind of like in order to write a Rails application, you got to know Ruby. In order to work with most of the modern ML stuff, you've got to learn Python. And probably Octave and R, and we'll show you why in a second. Right? And then after that, you're going to have to learn some new frameworks. Not a big deal, but there are a lot of frameworks that actually take on and they build on top of all the other things that came before. So in order to actually understand and use those frameworks, you've got to know everything that came before. Otherwise, once again, you're going to get another answer that's going to be 0.22, not 0.2, and then you're going to go, shit, right? And finally, let's see if we can go back one. Pick a project. What ends up happening when you work with all this stuff is you're going to find that you are actually much more driven if you have a project. I don't care if it's predicting how much money you're going to lose in the stock market, or how much you should spend on your Christmas gift for your friends, or maybe try and guess what, a bad thing somebody's gonna try and buy you for Christmas. Pick a project and keep working through that project repeatedly, and that'll actually start giving you this a context. It's kind of the same way that we use programming commands. You've seen FizzBuzz. How many people have seen FizzBuzz? How many people never want to see that in an interview ever again? Right? So pick a project and work with it, and that'll actually help keep you motivated to learn this stuff, right? So now we're going to give you the map that goes through this stuff. And it's literally, this is a way, not the way, right? And what I'm trying to do is I figure programmers are both lazy, right? In a really weird way, we will spend 2 hours fixing our Emacs or Vim configs just to make sure that we can save exactly one keystroke, right? You got to learn calculus. And don't worry, remember all the links that I'm going to mention I will actually post in something else. The best way that I found to learn calculus is you can do one of two things. There's MIT OpenCourseWare. Have you guys heard of it? It's really, really, really great teachers who record all their presentations. Gilbert Strang has a calculus class that starts with applied calculus and goes from there. It's one of the easiest and most accessible calculus classes I have ever seen because it's designed specifically for engineers. It doesn't start with the theoretical underpinnings. It starts with, well, how fast is this car going, right? Khan Academy also has a calculus course that's pretty good. Even if you have had calculus, I would go back and review it because frankly, when I started getting into this stuff, I'm I know calculus, and I'll tell you 3 equations in, I'm apparently I forgot all my calculus. Right? Linear algebra. This actually is a picture of a book by Jim Heffron. He actually wrote an approachable linear algebra book. I know this because I've taken linear algebra no less than 4 times. And I won't tell you the grades that I got in the first 2. Linear algebra is really essential for many of the applications that we use in machine learning. And if you haven't seen linear algebra, or you have what I did, which is I got the engineer's version of linear algebra, that's not the same one that they use in machine learning. The one they use is the one that the mathematicians use. Big difference, right? There's engineering linear algebra, mathematician linear algebra. You really need to review what's going on here because most of the manipulations that we do with data involve matrices. And in fact, if you think about all the acceleration that we've seen in machine learning, it's because of a lot of the stuff in matrix algebra and things like CUDA and what we'd otherwise refer to as massively parallel computations. They manipulate matrices really, really, really fast. So the same stuff that allows us to draw, say, Overwatch in 1080p at 60 frames a second is the exact same thing that allows you to predict which movie you're going to like on Netflix. So you've got to be familiar with linear algebra. After that, I hate to say it, you're going to have to read some books, right? Peter Flack still wrote the most approachable book in machine learning that I've ever seen, and then the fact that it gently introduces the mathematics, but it clearly explains using plain English and small words, 2 syllables or less, what's going on in a machine learning system, right? And he's out of, I think, Bristol, in University of Bristol in the UK. I still recommend this book for anybody, even if you just want a general survey of what a machine learning algorithm is doing. He talks about all the individual components pretty much of every single machine learning technique. And you've got to remember, one of the things we have to separate, in the same way that we might separate design patterns from implementation in software, we have to separate understanding what the technique does from the implementation of said technique. And one of the biggest problems is that oftentimes in literature, they don't separate the two. They don't tell you when they're explaining theory and when they're explaining application. So he gives you a very good separation of this is the theory behind X, and here's the implementation of X. And he does it in a way that you can read and not immediately fall asleep, within 3 or 4 minutes. Let's see. After you've read through Peter's book and worked through some of the exercises, you actually have to learn another language, Octave. How many people here have ever heard of MATLAB? Did you have it in school? We have probably, you had to use it in maths, for math labs in school. So the reason I picked Octave over MATLAB is because MATLAB starts at about $2,000 for a license for commercial usage. You can get home usage licenses for about $149, but if you're going to use it at work, it starts at $2,000, and by the time you get the machine learning libraries, it's about $6,000 for a license. It's eye-wateringly expensive, right? So unless you got an extra $6,000 lying around, in which case, come talk to me. Octave is MATLAB compatible, and it's free. The problem with it is that it's, like all free software, it's a little quirky, right? But it's for the most part, if you see an example that's written in MATLAB, it will work in Octave, or somebody has implemented it in Octave, right? So you're going to actually have to learn how to program in Octave. It's a scripting language. I specifically picked Octave instead of R as a language to learn is because Octave is generally easier for programmers who have used procedural, imperative programming languages to learn than R for various reasons, but just trust me on that one. And because we're going to sneak in R later. After you learn a little bit of Octave, how many people here have actually heard of Coursera? Okay, good number. How many people have actually taken a Coursera course? Anyone? There's a few. Okay. There's a guy named Andrew Ng. He pretty much has taught, I don't know if it is the most popular course on Coursera, but I think it is. And it is probably the best course on machine learning that you're ever going to get. He glosses over a lot of the math. He kind of assumes that you have a background in it. But what he does is he gives you concrete examples of, essentially of survey across the breadth of all the machine learning techniques. It's about 12 weeks. It's actually a really great course. If you already have a background in math and you've actually read some of these things, you can just go and you can grab that course and take it, and it'll actually give you a solid introduction to the basics of machine learning. I will say that it is not easy, right? Even for a Coursera course, like writing through and going through and programming some of the assignments, because you have to write code for the assignments. If you don't know MATLAB or Octave and you're not as familiar, getting some of them to work can be challenging, right? So that's one of the reasons why we're introducing these things exactly in this sequence, right? Then after that, there's another book, right? So literally, these guys wrote the original book on statistical learning. And there's a funny story about this book. In short, you can summarize it as thus. We wrote a book on statistical learning. Not even other PhDs could understand it, so we wrote this one for you fucktards. That's this book. It literally is a dumbed-down version of their other book. There's another book called The Elements of Statistical Learning, which for a very long time was the implementation Bible for machine learning algorithms. And it had exhausting, painful detail about implementing a machine learning algorithm. And I mean down to here's exactly how you can optimize this inner loop sort of stuff. Nobody could understand it except other people with PhDs. So they wrote this one as an accessible version of the material in that book. And as it turns out, this is where I sneak in some R. The examples in this book are in a statistical computing language called R, which also, unless you've been under a rock, you've probably heard of. Yes? R isn't necessarily as popular because it doesn't necessarily translate well to direct implementations like Python does. Like it's very hard to take a production, like a model written in R and move it to production without rewriting some R parts of it. The examples are in R, but you can still do them in Python, right? And what's important about this book is that it goes through and it takes all the basic elements of a machine learning or AI system and it explains them to you one at a time with an example. So you can read a chapter, go do it, and you can be like, I think I got regression. You read another chapter and be like, I think I've got clustering. The book is dense, but approachable, right? So like I said, you're gonna have to learn Python, get over it. On top of that, people really don't use Python to do machine learning. They actually use a whole bunch of libraries, scikit-learn, NumPy, and pandas. It doesn't really matter. One does a bunch of mathematics, one does a bunch of stuff with arrays, and the other one is actually a way to work on data manipulations. Once again, all this stuff will be in the PDF. Conveniently, there is a book that teaches you Python and all of those libraries for numerical computing. And it's this book, Python for Data Analysis. I couldn't find a high-res picture because the only place this early release is available right now, I think, is on Safari Books Online. But Wes McKinney is the guy who wrote Pandas, which is one of the main use libraries there. So as a result, this is what we got. So this is it. That's your roadmap. Right? Pretty simple. So get used to being confused, right? Because it's going to happen. Take your time. Like, I do not think you can actually get through this in under a year. Like, this is not a short path. If you want to go do this and you want to actually be able to apply it, you're looking at probably taking 1 to 2 years to do this. I've been studying this for 10 and I now just barely feel competent. Get used to reading. You're going to have to read a lot of stuff and a lot of it's going to be painful. Take notes. Like, take your own notes. When something basically gets translated from academic down to something you understand, write down what it means to you, right? And then try and do something every day. Like, try and do something, read something every day, read a blog post, do something, learn an equation, read something in one of those books, because that'll keep it fresh. And remember, you are always going to be at the end of your proverbial rope when it comes to this stuff. It's not easy. And there's always the internet for help. So the question is, why would we care about this? Ordinarily in a talk, we'd invert these two things. We tell you why we care, and then we'd show you how to care about it, right? So why do we give a fuck about any of this stuff? Well, as it turns out, there's now an AI that can improve selfies. Adobe wrote one. Like, this is a positive use of all the massive computing power that we've been harnessing over the millennia of evolution. We can now improve your selfies automatically. People are using AIs to write scripts. So we might actually never see another Transformers movie in our lifetime. Video games. I don't know if anybody here works in the gaming industry, but it turns out that trying to make facial animation, actually, has anybody ever played the video game where the lips do not match the audio? And it's just, it like drives you nuts? So now they actually have an AI that will go through and take a video of a face actor and map it to a 3-dimensional mesh and record the animation, right? They taught an AI to do this. They also taught an AI to write malware. So there's a malware that they wrote that with 15 hours of training was able to create a malware variant that could escape most detection with a 90% rating. Oh, I'm sorry, 60%. You can put people out of work. Every single one of these jobs on this little eye chart here has a 95% chance of actually being obsolete within the next 10 years and more than 95 in 20. Right? This is what the chart looks like. Those jobs on either end, basically, these are the ones that are going to go away. One estimate put the jobs, by the way, at about 47% of people who are currently employed could be unemployed by an artificial intelligence or machine learning system in the next 20 to 40 years. Just for reference, the Great Depression was 25% unemployment. Anybody who knows whose icon this is? Who is it?
It's the Microsoft chatbot.
That's right, the Microsoft chatbot, Tay. Tay learned how to be a racist individual and Holocaust denier in under 24 hours, which is amazing even for Microsoft. Anybody know what this is? That's right, this is the Tesla where the guy was actually driving, he had a DVD player, and the car was not unable to interpret the fact that on a high contrast background that there was a vehicle crossing the road. And as such, it didn't apply the auto braking. The car was not at fault. It's not a self-driving car. But clearly, there was an error in the software. It didn't detect that something was there. This is a taxi that's been burned out in South Africa because there's a taxi war going on because Uber is actually undermining the ability of taxi drivers to make a living. They've started burning and attacking Uber cars. 3 cars were actually burned in this incident. I don't believe anybody was killed. But there's an actual war going on in South Africa right now over this. Anybody remember this one? Uncomfortable silence. It's okay, I'm black. We can talk about this, right? This would be the one where Google's image search started classifying people as gorillas. Yeah, a little embarrassing. More embarrassing when you get an MQ-9 Reaper drone. Because you guys have all seen some of the leaks that have happened, right? We use metadata to target people. So what happens when you would do this and you say threat and you have an MQ-9 that's on station? Right? Booby. My pal, you guys know who this is, right? Yes. Artificial intelligence is the future. Not only for Russia, but for all humankind. Whoever becomes the leader in this sphere will become the ruler of the world. Need we say more? Of course we do, because these are actually the images that were otherwise posted by bots to a Facebook group that was traced back to the Soviet Union, or Russia, or whatever they are these days. So these were some of the memes that the bots were actually going. These were generated by sampling what people were going to be responsive for, generating likely response curves, and then coming up with messages that would actually resonate with people. All well within the purview of machine learning. That would be until Facebook actually otherwise decided that they can sell advertising to people based on teens in desperate emotional states, such as, I want to get this right, worthless, insecure, defeated, anxious, silly, useless, stupid, overwhelmed, stressed, and a failure. So if you want to target kids with things, hey, we've got the kids who are desperate and are going to buy your product, and we can tell you exactly when they're most vulnerable, right? And of course, the granddaddy of them all. Anybody know the story of the IBM Hollerith cards? So as it turns out, when Hitler was implementing the final solution, there was no way at the time that the census was being correlated by hand could determine where all the Jews were in Germany. They bought a system from IBM Germany that used punch cards to tabulate, identify, locate, and otherwise segregate Jews into the ghettos. And it worked so efficiently that they were able to roll into a town, identify all the Jews, and within 24 hours have them on a train. The machines were leased from IBM. The only source for Hollerith cards was IBM. IBM headquarters in New York knew about it. And nobody actually said anything. Multiple iterations of the software at the time, which was really a series of punch cards, were written and implemented to actually make this more efficient. Right? Not where we thought we were going to end up, was it? Right? So you're probably having sort of a huge what the fuck moment right now, which is wait. I was just coming here to learn some stats, dude. So as it turns out, I'm sure you guys have all heard about the phrase software is eating the world, right? Well, as it turns out, when you eat, sometimes you gotta shit. And if we're not careful, it's possible the software that we're writing today that's eating the world will be shitting all over it tomorrow, right? The system that we write today that's targeting people overseas can be used on US citizens. It doesn't care where the metadata comes from. The system that's targeting vulnerable teenagers today can be used to target your loved ones tomorrow who might be having an emotional or mental crisis, right? The self-driving software that we actually have today for those cars might be the one that runs over a small child in the middle of a street, right? So this is kind of a heavy message to drop on you guys, and it's a little bit of a bait and switch, but we're in an era where the software we write matters. You know what? I think one of the original hacker biographies was called Just for Fun, right? I used to be a phone freak. I used to like war dialing. I used to do some credit card stuff that would probably get me arrested and thrown in federal prison now. But we were just having fun. We never thought of it as really committing crimes or actually having an impact. But as it turns out, not only does the software that everybody in this room writes doesn't matter, when we start moving into a system where these systems will start making decisions about the real world, about real people, it really matters. It's no longer an abstract thing, right? So as you start learning these things, keep in mind, if you guys don't do it, somebody will. Somebody is going to implement that algorithm that's going to give out a loan. Somebody's going to implement that algorithm that's going to let somebody into college. Somebody's going to implement that algorithm that determines whether or not you actually get paroled, which, by the way, there was already one of those and people are suing over it because, as it turns out, Mexicans and black people don't get parole when they actually go through an automated system because it encodes the biases of the system that already exist. So let's bring it back up a little bit. We've got one treat for you because I did kind of trick you and made you feel a little heavy and depressed, right? For the truly lazy, you can actually get through this by reading 3 books. You can read the machine learning book, you can read the introductory statistical learning book, and then you should read these 2 books after you do that. Weapons of Math Destruction, Cathy O'Neil. She was a quant on Wall Street until she realized a lot of the things that she was doing were actually destroying and making America worse. She describes in intimate detail how these systems, which are said to be faultless, are really just encoding our own biases and are actually just allowing people to validate many of their own prejudices using numbers in the power of statistics. And this is a fun one. If for no other reason, it's a intimately researched portrait of exactly how software was basically at the root of one of the biggest travesties in humanity, right? Which is somewhat relevant in an age where we have a Microsoft chatbot that is denying that this even happened, right? That's what I've got for you. Hopefully what we're thinking about now is machine learning and AI actually holds a great potential for everything that we as software developers and we as people want to do. We want to change the world with what we do. We want to actually have an impact. But the thing that we need to remember is that it's a double-edged sword. What I'm giving you when I'm telling you actually how to build a statistical learning system is I'm basically almost giving you the exact same thing as it's a blueprint for building a shotgun, a pistol, a bomb, right? The impacts are felt no less, right? even if they aren't as obvious. So go off, become a machine learning engineer, but do it in a responsible manner. Think about what you're doing and think about the impact of that software, because in the end, it really truly does matter. Thank you.